In this video, we're going to talk about how to identify positions that result in a win either for you or your opponent that are horizontal. So, we're no longer looking at this vertical position. We're going to look at this horizontal position, which is slightly more complicated. And it's more complicated because we don't have to just look at 4 pieces now. We have to look at a 5th piece, which is the one below. So you can imagine a Connect 4 board. You know, these would be filled, obviously. We just don't care what values those are. A Connect 4 board where there is a red piece here, and then 3 red pieces here, and if the person moves here on the next turn, they will win. So you want to either block that, or if it's yellow, or if it's your color, you want to take it. So you create a win for yourself. The problem comes with, like, what if horizontal win is here? You know, so what if these 3 pieces are red and this one is open? Well, if our method takes into account this stuff, it'll go out of bounds down here. So we're going to have to deal with that situation later. But similarly, we're going to start, these are the originating positions for our loops, because we know that we want to check, this box, we want to check this section to find any possibilities of horizontal wins, either for ourselves or for the opponent. So we're going to design a similar method, but it's a little more complicated because there are different things that you need to look for. So let's head over to our player class, and I'm doing this in test player, but you obviously can just program this in your player's class. So we're going to create another method called horMove, horizontal move. It will also take in or request as a parameter the current state of the board. And, it's able to do this because it's been given the current state of the board by the game class every time it's required to give a choice back. So we're just going to kind of pass that along through the methods. And we also want to say a piece color, so red or yellow, depending on what we're looking for. Similarly to the previous one, we're going to set up this column choice, and we're going to return the column choice here at the end of our method, starting with a value of -1 to say, no, we didn't find any horizontal moves. You can look elsewhere for a position. But if we do find one, we're going to send back the column choice that is appropriate given that horizontal position. Okay. So how do we do this? Well, again, we're going to need to set up some loops to look over the originating position, like the top left. That's how I'm doing it. The top left position for this, for an 8-block piece of the board. And these are all the originating positions that we're going to use. And I'll deal with this edge case in a particular way that'll become useful for you as you go forward. Okay, so what are we going to look for? Well, we need to look at how many rows in this case. Let's do that loop first. And we see that we need to start looking for the pattern at all the rows, because any row can contain a horizontal win. So let's design that loop. For int, I'll use O row again, starting at the 0th row, the 0th row. We want this O row to continue as long as it's less than, what's the ultimate value here? Less than 1 greater than this, so less than 6. And we want O row each time through our loop to be incremented by 1. All right. Well, let's design the column loop now. Again, just looking at the locations that we want the pattern recognition part of our method to originate, and that is up here. So we want it to originate in all these columns, but if it originated in this column, it would go out of bounds, and we'd be over here and the computer would crash. The program would crash. So we know that we needed the column value to be less than 4. It cannot be 4, otherwise we're going to go out of bounds. All right, so for int ocall equals 0, ocall is less than 4, ocall plus plus. So we have our loops correctly built at this point. But now we need to start to get these A, B, C, D variables just to make this if statement easier to write. I mean, you could write all this mumbo jumbo in the if statement. It'd just be like, 2 feet off to the right of the screen. So I'm going to just create these integers so it's easier for me to remember. I'm going to give names to things and write down their positions. All right, so these things are going to be pretty similar, so I'll just copy this, the A, B, C, and D ones, because they're not going to go out of bounds. So the A, B, C, and D, and it's helpful to have diagrams written down. So A, B, C, and D in my world are going to be these 4. Okay, so the originating A is at O row, O col. But then B is not going to be at O row plus 1. It's going to be at O col plus 1. C at O col plus 2. D at O col plus 3. So because I copy and pasted, we need to be careful to adjust these things. They're all in the same row, but they're all at different columns. Now, because if we just did this for E, F, G, and H now for these lower positions, as soon as the originating position is here, we would be out of bounds because we'd be down here looking for those things. So I have to account for that with an if check. And the way I'm going to do this is I'm going to say if O row plus 1 is less than 6, I know we're in bounds, and so I'm going to create those variables with the actual board, with the actual values in the board, because we're in bounds here. Here we're out of bounds, so we need to do something different. Out of bounds. And because of these braces, we don't want to create the variables inside these braces because variables are only exist inside the braces in which they were created. So I'm just going to create these variables up here, and then we're going to make use of them down below. So I want to create an E, F, G, and H integer. And then if we're in bounds, I am going to have the values of these integers O row plus 1, so that's right below the position that, the horizontal move that we're looking for. And O col will be in the same kind of sequence as those up there. So right now we have these correctly set up, but we haven't dealt with a case where we're out of bounds. Well, if we're out of bounds, we just need those pieces to be filled, which is indicated by a non-zero value. So you can frankly choose any value right now. I'm just going to choose 1, but you could choose like 426. It doesn't matter because the way I'm going to write the if check will just say like if it's not 0, do something. So I'm going to say if we're out of bounds with this, I'm going to just give E, F, G, H the value of filled with something so that we can know, yeah, there's stuff down there. If you put a piece in there, it's going to land on top of something, whether that's the bottom of the board or, a piece. So E equals F equals G equals H equals some non-zero value. All right, well, we have these things set up correctly now. So now all we have to do is write the if checks inside the, now check for the position. So let's go back to our diagram and see what is the thing that we're looking for. Well, we want A to be empty, B to be filled, and C and D with one color, so the piece color. And we want E to be filled. It doesn't matter if it's red or yellow. We just need to have something on which to set this piece. And we don't care what the values are under these values, because in Connect 4 you cannot have a piece hovering above nothingness. So we just don't care. We're just unconcerned with what these are. We assume they're filled because these are filled. Okay, So let's go write that. This one needs to be open, this one needs to be filled, and these three need to be the piece color. All right. So if A is the piece color, or no, if A is empty, which is denoted by a 0, and B is the piece color, and C is the piece color, and D is the piece color, well, we have found the position now, but we're still not sure if we can put a piece there for the win, because what if this were open and this were filled? Well, we'd put a piece down there and then we just like either give up the winning position or allow them to win. So we don't want to do that. Well, so we need to make sure E is filled, is non-zero. All right, so and E does not equal empty. So if it's not empty, then we know that col choice should be the originating column value, because the originating column value is always in my methods the top left position. So this pattern originated in column 3, which is, denoted by, this is the originating square. And so we have located a pattern in which we should, that we should target for a move. So we do that here. The column choice equals the originating column. Now, we are not, equals. We are not actually done, right? And so in the subsequent video, we're going to deal with a situation where this is filled, but this one is empty, and this one is filled. So we have this kind of interior horizontal wind structure, and we're going to deal with those things in the subsequent video because I feel like this is getting a bit long.